So welcome to another segment of my physics videos as we look at transformers. So what exactly is a transformer? Well, we can say that a transformer is a device that varies voltage of an AC supply, or we can simply say that a transformer is an electric device that transfers electrical energy from one circuit to another by electromagnetic induction. Now, in transferring this energy, a transformer can step up or step down the voltage from the source. That is what you need to remember. Now, what are the components of what we are calling as being a transformer? Well, when we talk about a transformer, maybe I can talk about just components to simplify things. So a transformer consists of two coils. So one, we can simply say it consists of two coils insulated from each other and wound on the same soft iron core. So that is what you need to remember. So another component that you're going to find is that while it consists of two coils insulated, so you're going to find that the core connected to the AC supply, you can simply say that the coil connected, so the core connected to the AC supply, so that core connected to the AC supply is called the primary. So we call it as being the primary coil. So that is what we simply call it. And we can simply say that the coil connected to the electrical appliance. In this case, when I say electrical appliance, I mean it could be a lamp, a bulb, whatever electrical appliance. So the core connected to the electrical appliance is called the secondary. So that is called as being the secondary core. That is what you need to remember. So in simple terms, if we were to draw a simple transformer, it would look something like this. So you have what we are calling as being, this is what we are calling as being the soft iron core. So there's a part that is connected. So this is the coil that is connected to the AC supply. So this is what we are calling as being the AC supply. And we can say this is the part that is connected to the electrical component, maybe such a thing such as a lamp. That is what we are talking about. So you are going to find that this is what we are calling the soft iron core, but we can call it as being a laminated. So we can call it as being a laminated, soft iron core. So that is what we can call it. So you can notice that we have got two cores. So the part of the coil connected to the AC supply, this is what we simply call as being the primary. So this is what we call as being the primary core. Then the part connected to the load or the electrical appliance, this is what we call as being the secondary. This is what we call as being the secondary core. So that is what you need to remember. Now, of course, if you look at the wires, the number of the wires that are wound on the primary core, we can refer to those as being number of turns. So the number of turns on the primary. So I can simply say the number of turns on the primary, NP, and of course the number of turns that we have on the secondary, we can refer to them as being the number of turns on the secondary. I can say NS. So that is what you need to remember. The current that will pass through the secondary core, we can call it as being current secondary. I'll say IS. And the voltage that we are going to have passing through the secondary core, we are going to call it as being voltage, secondary. On the other hand, we can also say the current that will pass through the primary core, we can call it as being current primary, while the voltage that will pass through the primary core, we can call it as being voltage primary. So those are concepts that you need, to remember about what we are calling as being a transformer. But I can give you, there are two types of transformer, so we can talk about types of transformer. So there are two types of transformers, that you are going to be finding in the exam. So it is either you are dealing with what we are calling as being a step-up transformer. Now, how can you know that this is a step-up transformer? Well, for a step-up transformer, you are going to find that the number of turns in what we are calling as being the secondary will be greater than the number of turns in the primary. And therefore, the voltage in the secondary will also be greater than the voltage in the primary. It simply means that the current passing through the secondary core will also be less than the current in the primary. So when you find that this is true, then we call it as being a step-up transformer. Now remember, the symbol for a transformer may look like this. This is the symbol that we can use for a transformer. So you may find something like this. So this is what we call as being the circuit symbol of a transformer. Now, in most cases, when we look at this one in the exam, they can simply tell you to draw what we are calling as being a step-up transformer. So when drawing it, you are going to have more number of turns on the secondary than on the primary. So using the circuit symbol, maybe I would actually write it in this way. So I can draw it in this way, just in simple terms, using the circuit. So remember, this is the part connected to the AC supply. If you want, you can put up that. Then you can have more number of turns on what we are calling as being, the secondary, where the electrical appliance will be put up. Remember, this is where you have the AC supply. So you can see you have got more number of turns on what we are calling as being the secondary as compared to the primary. And it is true, if your voltage, for example, in the primary is actually going to be less than what you're going to have in that direction, then such a transformer is what we are calling as being a step-up transformer. Now let's give you some other concept. The other type of a transformer that you're going to be finding in the exam is what we are simply calling as being a step-down transformer. So you're going to find a step-down transformer. So how can you tell that this is a step-down transformer? Well, in a step-down transformer, you need to remember that the number of turns in the primary is greater than the number of turns in the secondary. It simply means that the voltage in the primary will be greater than the voltage in the secondary, and therefore the current in the primary will be less than the current in the secondary. So when you find that, then just know that it is a step-down transformer. Of course, how can you write this? Well, you need to have more turns on the primary. So if I was to use the circuit symbol, you are going to have more number of turns. You are going to have more number of turns on the primary, and you are going to have fewer number of turns on what we are calling as being the secondary. Remember, that is representing a lamp somewhere there. So you can see you have more number of turns on what we are calling as being the primary as compared to the number of turns. So it simply means that the voltage, for example, if this side I'm using 240 volts, the voltage that will pass across the secondary may simply be 120. So you can see the voltage in the primary is greater than the voltage in the secondary. So this is what we call as being a step-down transformer. Of course, there are so many ways that a person can actually draw such transformers. Like I started, you can actually get to use that. Now let's talk about what we are calling as being an ideal transformer. So in an ideal transformer. So in an ideal transformer, I'm simply talking about a transformer that is 100% efficient, meaning that there's no power loss whatsoever. So we are going to be using the word ideal transformer, meaning that it is 100% efficient. Well, in an ideal transformer, it simply means that the power that you are going to have. So the power that you are going to have. So the primary core sometimes is known as being the input, and the secondary core is known as the output. So that is what you need to remember. So in the primary, they can call it as being the input, and the secondary is known as the output. So in an ideal transformer, you're going to find that the power input will be equal to what we are calling as being the power output. But if you remember from what we did under electricity, we did say that power is equal to voltage times current. So we can simply say the power input will be equal to the power output. But power is simply given by voltage times current, which is equal to voltage times current. But remember, because that's the input, if you want, you can say voltage in the input or primary times the current in the primary will be equal to voltage secondary and current secondary. So we are going to be using this one to do some calculations. But of course, you need to remember that power in the input is equal to voltage primary times current primary, and the power in the output is equal to voltage secondary and current secondary. So these are concepts that you need to remember. Now we can rewrite this formula in this way. We can just summarize that one and simply say, the number of turns in the primary over the number of turns in the secondary will be equal to the voltage in the primary over the voltage in the secondary, which is equal to the current secondary and the current primary. I've not changed anything. You can also use this to do some calculation. For example, you may be comparing N, the number of turns, and the voltage. So meaning it will be NP over NS is equal to VP over VS. Or you can be comparing the number of turns and the current, meaning it will be NP over NS is equal to IS over IP. Or you can be comparing the voltage and the current. It depends with what information you have been given in the question there. So that is what we mean. So basically, this is what we can use. And if you look at the last one, when you cross multiply the last one, it will give us what we said, that in an ideal transformer, the power input will be equal to the power output. Because when you cross multiply this times that, to give you VP IP, which is equal to this times that will give you VS and IS. So you can see that I've not changed anything here. This formula will just help you to deal with different situations, as I'm going to show you in some more practice questions that we are going to look at. All right. So now at this point, I can simply talk about, I can simply tell you that there's no transformer in reality that is 100% efficient. There will always be energy, losses. So there will always be energy losses in a transformer. So in what ways is energy going to be lost in a transformer? So we can say, energy is lost in a transformer. So energy will always be lost in a transformer. How is that energy going to be lost? One, we can simply say that because there are what we call eddy currents, so very small currents that are going to be created in the transformer, because the transformer is heating up, so small currents are going to be created, and because of these eddy currents, you are going to find that energy is going to be lost. Then of course we can say that there is leakage. So there is leakage of magnetic, so there is always leakage of magnetic flux. So not all the magnetic fields produced in the primary core is going to be connected to the secondary core via the ion core. There's always going to be a leakage that is going to be there. So because of that leakage, energy is actually going to be lost in a transformer. So sometimes, the transformer produces, heat, sound, so energy is going to be lost. So I can simply say that energy is lost in form of heat, sound. Yeah, so it can be lost in form of heat, sound. So that is why when you go near a machine, a transformer, you're going to be finding that, sound is going to be generated and hence it will be produced. So energy can be lost in such ways. So now, what are some ways of preventing or reducing heat loss? So we can talk about, ways of reducing ways of reducing energy losses in a transformer. So what are some ways of reducing energy losses in a transformer? So now there are so many ways that we can reduce energy losses in a transformer. Number one, you can simply talk about using thicker copper. So using thicker copper wires. So you can use thicker copper wires. Why do we want to use thicker copper wires? To prevent overheating. So that is what we want to do. So one way you can reduce energy losses in a transformer is simply by using thicker copper wires. They help to prevent overheating. Another way that we can reduce energy loss in a transformer that we can talk about is one, we can simply say that's number two, sorry. So we can simply say using a laminated, soft iron core. So that is what we mean. So using a laminated, soft iron core. Then the third one that you can do, so you can say using, soft iron as the core of the transformer. So these are ways that you can actually help to reduce or to minimize energy losses that take place in a transformer. So I'm going to show you some more practice questions that we are going to look at. So please watch out for my next video as I look at practice questions on how you can go about calculating, using the formulas that I've shown you here. Thank you so much for watching.